Okay, so arithmetic operator we have seen. Just we got little confused with this slash and double slash, but I think now we know how this works. So I'll start with this exponent, right? This exponent is a power. This 2 sign is a exponent. It's a power. So like x into y, if I do, this will be very big number, right? 10 to the power 20. It's like very huge number. So I'll keep it little simple. I'll say to the power 5. Okay. So I'll make it this x as 2 and y as 5. Then we'll see how this works, how this exponent thing will work. Here, or I'll directly print the value. Okay. Print 2 exponent 5. So this line is saying 2 to the power 5, which means 2 5 times, which is 32. So answer should be should be 32, and this is my answer, guys. So simple exponent. After arithmetic operator, comparison operators. Relational, it is also known as a relational operators. So how will relate one variable with second variable, or one variable with multiple variables? We can check whether they are greater than second variable, less than second variable, equal to, not equal to. Okay, this is a sign. So let's understand the sign first. And you must have seen this sign in an operation of C also. So while working with the C, this was our first programming language. While doing this, some of the programs here, or maybe if you have involved in CPB, we have used this ample amount of time. This is the less than sign. This is the greater than sign. Okay. This is equal to, yesterday I've shown this. This is not equal to, this is less than and equal to, this is greater than and equal to. Okay, so whichever value, like if I say x comma y, obviously x is bigger here. If I make it this, my y is bigger. So we'll keep two values, a is equal to 10 and b is equal to 20. So we assign two values, a is equal to 10 and b is equal to 20. And remember guys, when you are working with a comparison operators, this is not returning you any numeric output, right? This is returning you Boolean output. So whenever you perform logical operators, concept of different gates, and or XOR, not, or when you perform this comparison operators, so answer will always be a Boolean. Output will be in Boolean, and Boolean answer is true and false. So if it is matching, it will pop you, it will display you true. If it is not matching, it will display you false. In other word, we can say in computer, or what is a human interpretation, how human have designed plus and minus, right? So human says that if it is 0, it's a false. If it is 1, it's a true, right? This is what our binary form says. This is the binary value. This is false, this is true, number wise. And this is if I say T and F. So but I'll get answer in this form, T and F. I will not get answer in this form, because for this I need to convert my this values. Okay, and that we'll see in a bitwise operator. How can we convert any number into the binary operators, or any binary values using decimal, hexadecimal, or whatever format we are going to apply. So comparison answer will come in a Boolean, and that too in a true and false, 0 and 1. A is less than B. So yeah, that's right. 10 is less than 20. This is right. If I'm printing this one, I'll get it true as answer. A is not equal to, the sign is not equal to. So 10 is obviously not equal to 20. This is also true. Both value are not same. This is also true. A is greater than equal to B. Never. A cannot be. I can write this way, or I can write the same statement like this way also. So I know these are very basics we have seen already, but just remember this this couple of things. Like for the same answer, we are using different denotions. Okay, so this will be false because the condition itself is wrong. Comparison operator, simple, straightforward. No, you're not writing any logic or any condition or any for loop or your iterable dealing with the multiple elements. You're not nothing. You're not doing anything. These operators will be used within the conditions. So at least in this operator side, this has a meaning. This if I move this value in a different angle, this has a meaning. This has a meaning. This is a cap, right? So technically, this is in sign also. If you see your keyboard in your computer, I think you can find this cap in a 6-digit. So this is nothing, but it's a XOR. It's not a NOT. XOR will combine NOT plus OR. So it's the same concept of gates, different logical gates in a physics. We'll see how this thing will work, because XOR and NOT in logical operator both are working differently, and we have to remember that. It's not that both will give me the same value. So when we'll go to logical operators, we'll say I think after comparison we have the same thing. After comparison we have the logical operators only. We use this operators many times. Logical operators. And one thing to remember, we are currently in Python 3. We're currently in Python 3. So Python 3 will not understand the sign. This is also AND. This is also AND. This is OR. And this is NOT. Right? But this we used to give this sign in a Python 2. And this we're using in a Python 3. Okay, so there's a, you cannot use them. You cannot use the AND operator or operator, because maybe sometime they can give you exception. So it's better if this is not working, you can check them, and do not use 2 times double sign. Okay, because it is varying from one programming language to second programming language. Like if I do the same thing in Scala, and Java, then I'll be writing 2 times this to compare anything. And AND operator, how this AND operator will work, what is the use, what is the condition, what is the concept of this. But currently, remember, you are not going to use this, you're not going to use this. Okay, this will not work. So this thing will work in Python 3. And or you'll have to write in English, and or and not. Okay, let's start with the AND operator. What is a AND operator? AND operator says AND operator says AND operator, when both the condition is true, then only it returns as true. When, so please note down this, when both the condition is true, then final outcome is true. As in, if any of the condition is failed, right? So let me write one small block here. I'll say a is equal to 10. Okay, I say a is equal to 10, and then I'm giving one if condition here. I said if a is greater than 9 and, so this is my sign here I'm using, so it's better can I say and like this, and 11 is greater than a, then print me, then print me even number, then print me even number. So we use some punctuation, we use some notation in Python that I'll take it later, because here in Python you're not going to use this parenthesis. This parenthesis will not work. There's a difference between different programming languages, so do not go with the syntax. But if I consider this as my pseudocode, okay, this is my logic, plain logic, and I said else print odd number, very basic program. Odd number. So when I run this program in my Jupyter notebook, the cell, or maybe in PyCharm, so it will check first condition. This is true. This is also true. So when both the condition is true, then it prints this value. It goes inside the condition. Suppose I'm giving here a column. So when this condition is true, then only you go to this line, right? If this is not true, if any of the condition is failing, then print me else. So end is saying you, when both the condition is true within any if, else, for loop, while loop, then only return, then print output of that condition. But if I use here, I'll just change this operator, and now I'll say if 11 is less than a. Same thing, I just change this condition. So this is right, but this is wrong. The first condition is right, but the second condition is wrong. So whenever they found one condition is wrong, this is not matching with the condition, automatically it will not execute this line. It will not execute this line, right? It will directly jump to else and print me this, because one condition is fit. So what I have written here is justifying. When both the condition is true, then it prints output of that condition, whichever condition is suiting that value or that operators. Second is a or operators, right? Second is or operator. Now or operator is different than this. When one condition is true, any one condition, I'm not saying the first one has to be true. In end, what happens if first is false? It does not even check the second. It returns from here itself. It will not go and check the second, because any condition is failed, it's failed ultimately. But if it is or operator, right, when any one condition, again I'm not writing the order here, when any one condition is true, it execute the first condition. It execute the first condition or that condition. Can I say that in or operator? When any one condition is true. So in this case, let me take another example here. Let me say marks. So a student got a mark m is equal to 72, and here I'm creating one statement. If mark is less than 100, or, so write this or or 150 is less than m. So this is my comparison operator, and I'm using combining logical gate there. or operator, right? So two operators I'm using here. Print me pass, else print me fail. Now if I check this block, my this condition is true. 72 is less than 100, but this is not true. 150 is not less than 72. This is false, but still it will print me pass, because in our or operator we are checking just one condition to be true, whether the first one or the second one. This is or operator. Not operator is just opposite. Not operator is just opposite. This is just opposite. So you'll see not in this example, in third example, how we are using this not. I said here A is equal to true and B is equal to false. So can you understand, this is 1, this is 0 technically, and I said print not B. Getting me? I said print not B. So B value is already false. What is the opposite of false? Opposite of false is true. If I make this B as true and opposite of B will be false, right? So when I said this one, it is printing me true. When I say print A and B, A is true, B is false. Both are not true. And whenever both are not true, we get a false. That's what AND operator is. And when any condition is true, it is true. This is OR operator. So here we have one condition true. I hope it's clear how we are going to use this logical operators. And now the most important operator, tricky operator is this bitwise operator. And different signs we have here. AND operator, same as above. OR operator, same as above. NOT operator. This is a bitwise NOT operator. Okay, this is a bitwise NOT operator. This is a bitwise XOR operator. This is a right shifting. Sorry, this is a this is a right shifting. So I'll tell you how the right shifting and left shifting works. This is the right shifting, and this is the left shifting. So these are just sign of your operators. We'll see all of them one by one. How every single operator is working. This is simple, and one is simple. Clear? Not and just remember the not one, because in logical not sign is different, and here in bitwise operator we have a different sign for not. And okay, because this is a bitwise operator. Start with the one first. AND operator. It has given me two values. A is equal to. It has given me two values. A is equal to 9 and B is equal to 2. So couple of question guys to you. Do you know how to convert this 9 into binary? Do you know what can be the binary value of 9? How do we interpret this? Simple method. Just whenever you talk about bitwise, so I think somebody answered. Okay, Bhushan. Perfect. So yeah, just we'll revise once, okay? Bitwise, in bitwise operator, this base will have to convert into the power. Yeah, because in binary always we compare or count any value with 2 to the power. So this 9, how this can be written in 2 to the power, right? Just remember 2 to the power. So base has to be 2, and then exponent can be anything. It can be 3, 5 based on this value. So 9 can be a combination of 8 plus 1, Can be a 9, right? Because why I'm writing 8 specifically, why I'm not writing 6 plus 3 or 4 plus 5, because I know this 8 can be also referred as to the power 3. That's right. This 8 can be referred, because I'm saying only just one notation to remember. Everything has to be to the power. Nothing other than that. To the power 3. And how can I get this 1 to the power 0? This is what giving me binary operator for 9. So let's write the value. Total position, I'll keep it 4 by default, right? Total position will keep it 4 by default. So practice wise, I'll keep it 0, 0, 0, 0. Very simple first, just to express this thing. And position wise, this is my to the power 0 position. This is my to the power 1. This is my to the power 2. And this is my to the power 3, because maximum is to the power 3. If it is to the power 4, maybe I'm writing one more 0 here. Okay, just placing it. We have got two values, to the power 3 and to the power 0. So wherever you are getting values, please place 1 and 1, and rest of them are 0 and 0. This is what your bitwise says. Yeah. So 1001 is a binary or bitwise a value for A. And if you understand me now, for 2, it is just a to the power 1. And to the power 1, if you map with this, so we have value for this position only, second from the right and third from the left, right? So can I write this 2 to the power 1 as 0, 0, 1, 0? I can say this 0, 0, 1, 0. First I converted my A and B. So this is for 9 and this is for 2. Now I need to perform operation not in this. I need to perform my operation in this. And which operation? First I'm performing AND operation. So in AND operation, 1 and 0. I said 1 is a true, 0 is a false. And when true and false in AND operator, in this operator, let me write the sign of it. AND operator, 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. 1 and 0 is 0. So answer of this will be 0 numerically. Yeah, I'm making sense. A and B, answer will be 0. So we can do this. Can I just get one quick thing? If you have notebook, if you can answer me, guys, so we can quickly move and see some other example. Then A is equal to, let's say I'm giving you 11, and B is equal to 5. Can you tell me the end answer of this? If I perform AND operation on A and B after bitwise conversion, so what will be my answer? What I'll store in X? If I say X, A and B, what value will come when I print X? So 2 minutes I'll give. If you get answer, it's well and good. Otherwise, I'll solve it here. 0, 1, 0, 1. Bhushan answer is 1 plus 4. Bhushan's answer is 5 and Pallavi's. So both answer is different. I'll see which one is true. So according to Bhushan, answer is 5, and according to you, Pallavi, your answer is 1. As in the numeric value has to be 1 for 1 and second for 5. So I'll save answer somewhere here. Numeric value 5 and numeric value 1. Let me solve this. And B. Uh, 11 wrong. Okay, well, we'll see. No problem. 11 to the power 3. So first, I'll not directly write it, okay, because we're not computers. We will have to check this computation first. To the power 3 is 8. To the power 1 is 2. 8 plus 2, 10. And to the power 0. So in this, we do not have any value for to the power 2. Rest all we have. So can I say this is 1, 0, 1, 1? And B is to the power 2, 4, and to the power 0, 4 plus 1. We do not have any value for 2 to the power 3 and 2 to the power 1. So 0, 1, 0, 1. And if I check this, I think Pallavi answer was right. Answer for this to the power 0 and to the power 0 is nothing but numerically 1. So answer of this AND operator will give me numeric value 1. Perfect. And we know how AND operator will work. Another question. So I think again, you guys tell me. If B is 12 and C is 3, 5. So what is the answer of OR operation here? To perform OR operation, what is the answer? Numerically tell me, okay? Don't give me the binary number. Just tell me numerically. What is the numeric value of it? Thirteen and 15. So 13 and 15. Let me see. Both answer is different. So which one is true? B12. 12 means to the power 3. Now I'm writing directly my values since you guys know how to convert them. To the power 3, I have yes. To the power 2. So to the power 3 is 8 and to the power 2 is 4. So 8 plus 4 becomes 12. 1, 1, 0, 0. And for C, 5 to the power 2 plus to the power 0. To the power 2 plus to the power 0, 0, 0. So 1, 0, 1, 1. And answer is to the power 3 to the power 2. The answer is 13. To the power 3, 8. To the power 2, 4. To the power 0. and AND operator in OR we know. Now sifting, before sifting will come later. I'll see first NOT operator. Yeah, Bhushan, they're anyways a little tricky, so sometimes we confuse with the operations. Anyways, not a problem. Z is equal to 9 and print not Z we are saying, right? So Z is equal to 9 and we said not Z. We are saying not Z. So remember first, whenever you say not Z, okay, in bitwise operator, so first convert this 9. When I convert this 9, it will be 1, 0, 0, 1 to the power 3 to the power 0. 8 plus 1, 9. And we'll have to add minus 1 here. You have to add minus 1 here. Whenever you use this not operator, remember guys, whenever you use this not operator, you'll have to add minus 1 always. If I say Z is equal to 12, so first you'll convert that 12 in a binary and then you'll have to add minus 1. So answer is, there's a beautiful hack. You can, whenever this question comes, so you can say the answer of this, suppose I'm storing this answer in Y. So answer of this will be always 1 more than this with a negative answer. So if it is 9, it will be minus 10. I'll prove you how this is coming. But without calculating, without going to this part, you can directly tell me answer. This is your answer. If I give you z is equal to 13, if I give you z is equal to 13, so you can directly tell me the answer is minus 14. If I give you 8, you can tell me answer is minus 9. How this is done? But so for competitive exam, we can directly answer, no need to solve them to take extra time. But here we have ample amount of time. We have to solve it because we're not rectifying anything. This concept will come all in the Python different libraries, and we have to solve these questions there as well. Minus 1001 and 1 and 8 this. So what this says, what this not operator says, this 1 and 1 is a note. And why I'm noting, because the same thing here is denoting me different. And when I go to this operator, XOR operator, so this is not. When I move to XOR operator, the same value will return me different answer. So that's why this you'll have to remember. It's not the same logic which we are using here. It's a different logic we are using for especially NOT and XOR. And OR, I know it's very easy, but for this too, we use in some corners. We're not using heavily this in any Python programming or in machine learning applications. But yeah, you'd never know when the situation can come and this question can come, or maybe you have to implement this inside the application. XOR, I'll just take after this note. So note, I am saying when you perform any operation, when you perform any operation on 1 and 1, okay, when you perform any operation on 1 and 1, especially this 1 and 1, it returns always 0. It returns always 0. And like if I go to the core logic, how this thing is implemented, actually 1 and 0 is not, this is, we have interpreted 1 0 is computer interpretation, but for plus and minus, human has given their own interpretation, and plus we denote with 0 and minus we denote with 1. This is human interpretation, right? So 1 and 1, if I check 1 not, it is 0. If I check 1 not also, it is 0. So 0 is anyways 0. That way you can think, because anyways you need to convert the value. Or you can note this beautiful point. When you perform any operation on 1 and 1, it returns always 0. If it is 1 and 0, then if your question is, it is 1. If it is 1 and 0, it's 1. Because 1, when I change the value of 1, like when I inverse 1, it's 0. And when I inverse 0, it is 1. So ultimately it will be 1 only. Yeah, that way you can think. So this 1 and 1 is returning me 0 according to this. 0 and 0 is 0. 0 and 0 is 0. And 1 second, I think I just interchanged the OR operation answer. Just give me a few seconds, I'll correct it. This is 0, then 1. So yeah, right. Now this is good. But this is returning me 0. That's true. I forgot to mention one more thing here. So when you perform any operation on 1 and 1, it returns 0 always. It returns always 0. And carry forward. 1 to left value, or to left operation. So left value, I'll keep it. Left value means, as a simple maths concept, if I say 89 plus 5, if I'm doing this operation, so what we do, we add 9 plus 5, which is 4, and carry forwarded 1 goes to 8, and then we say this is 9 plus 5 is, yeah, that's right. So 94. This is a carry forward operation, right? 1 is a carry forwarded here. The same thing I'm saying here. in this. When 1 and 0, when 1 and 1 is there, it is 0. It is returning me 0. And carry forward 1 to the left value. This is my left value because this side is right, this side is the left. So 0 and 1 is carry forward. You imagine there is 1. So 0 and 1 is 1. When 1 and 1 is 0, 0 and 1 is 1. 0 is there and 1 is there. And minus is there. So this is your binary value. But again, if you convert this into numeric values, this is 0, 1, 2, 3 to the power 3, 0, 1. So this is to the power 1. To the power 3 is 8 plus 2, 10. And we have minus sign there. So this is minus 10. What I said, minus 1 extra value than whatever question I'm asking you. Z is equal to 9 was my question and the answer is minus 10. What I did, again I'll just revise and give you one question to solve. First I converted this 9 and said 1001, and then I'm adding minus 1 since this is not. So minus 1 and 1 and 1 is 0 in not operator, carry forwarded 1 and rest of same then. So only this point we'll have to remember, just this point. Note. So let me solve, because if I ask you for any value, you know the hack now. You can say next minus 1. Suppose I give you z is equal to 11, right? So 11, z is equal to 11, immediately in my mind says that answer is minus 12. I know the answer, but how to get the answer? Now this time quick. 1, 1 can be written as to the power 3 to the power 1 to the power 0. So 1, 0, 1, 1 minus 1, because this is what my not 11 will give me. 1, 1 becomes 0. There's again carry forwarded 1, right? And again 1, 1 becomes 0. Again 1 carry forwarded here and 1 carry forwarded here. So it's minus 1100. And this is to the power 3, this is to the power 2. 8 plus 4 becomes 12 and minus is there. Clear? How we can use this operator, not operator? Any confusion here, guys? Next. So after this 3 operator, we'll go to C or operators. We'll go to C or operators. Sorry, XOR operators. There's a question. Okay. Excuse me. A is 9 and A is 9 and B is 2. I'll take the same thing. Maybe I'm writing where I'm writing. I'm taking example of this line A1 and B1, right? So I'll take this one only. A1 and B1, 9 and 5. A1 and B1 is 9 and 5. 9, I can say 1, 0, 0, 1, and 5 can be known as 0, 1, 0, 1. Yeah. And we are using operator called XOR operator here. We're calling operator called XOR operator here. So XOR operator says, now I'll change the rule. I'll change the rule here. I'll change the rule here. When one and when we perform any operation, right? So when we apply not XOR operator on 1 and 1, as in this and this, 1 and 1, and I'm trying to aid this or whatever based on the operations. If there is nothing, we consider it as positive, right? So if there is nothing written, it's positive. It's technically 0. Before this, I have so many values. This 9 can be, I'm writing directly the 4 values. The same thing can be written as this 0, 0, 0, 0, 1, 0, 0, 1. This is what octal transformation of this value. And this can be written as 0, 0, 0, 0, sorry, 0 1 0 1. This is what is actual interpretation, but I'm just getting this because rest of them are anyway 0. Rest of them are anyway 0. That's I'm not writing. But internally system will understand, system is getting this value when I say 9. Yeah. So if there is nothing, it's a positive sign is 0. If there is something, we call 1, and as a negative is there, so we call 1. We apply not on 1 and 1, and it returns 0. There is no carry forward. There is no carry forward. It's not not operator that I'm saying 1 and 1 becomes 0 and then 1 will be carry forwarded. Okay, so there is no carry forward. When you apply, I'll just keep revise this because I know this is a new operator and sometimes even I confuse here between these two. So when we apply XOR on 1 and 1, it returns 0 and no carry forward, and it does not take any carry forward value. So if we write this notes, our life becomes very easy, and it does not take any carry forwarded value. So just looking at this statement, I think you can solve this problem now and tell me the answer. Can we say 1 and 1 becomes 0? That's what we have written, and it does not carry forward anything. So I'll not write 1 here. 1 1 0 0 0 1 is 1 1 0 is 1. So answer should be what? To the power 3 to the power 2. Answer should be 12. Let me see, because I'm also a bit confused to get the answer. Yeah, answer is right. I'm right with the concept. So answer is 12 for this operation number this. Print A1 and B1. That's what we're doing. A1 and B1 we have taken, we're using this operator. So answer is 12, guys. I hope you understand this. So in this two, there's a significance difference. This is carry forwarding. This is not carry forwarding. After knowing 4 operators, 2 more operators, right shifting and left shifting. So how this right shifting will work and how this left shifting. I have taken an example here. A left shifting 2 times, I'm saying. This means yes, Bhushan, we apply this. I'm not saying like heavily, like if I'm saying 100% time, I'm using 90% time AND operator and OR operator. So left shifting and right shifting can be used 5% and 10% time. But 90% time your basic operation will come. But yeah, just in order to explain, I'm doing this, okay, because we don't know when this question can come and we'll have to use this operator. So since this is new, I'm taking a little extra time. I'm going to use this right shifting and left shifting. So A is equal to 9 and B is equal to 2. 9, how this 9 can be written? Now please write, whenever you use the shifting, please write this 9 with octal value, 8 decimal values, right? So 9 can be written as to the power 3. So first I will write my actual value 1001. This is my actual, but I will do this as well. But if there is nothing, it's a 4 times 0. And I'm saying I want to shift this 2 times. I want to shift this 2 times with value called 2. When I'm saying I want to shift this 2 times value called 2, which means this 2 value will go there and become 0. So answer of this, A, right shifting B, 9, right shifting 2, this 2 will go there and become 0. This 2 will go, and why 2 if you ask me? Why 2 if you ask me? because I have written 2 here. If I written 3, I'll take this 3 value and keep it 0. So if I run this, it will give me 0, 0, 0, 0, 0, 0. 4 times 0 was already there. I keep it them. So 2 times more 0 and 1 and 0. So answer of this is to the power 1, and to the power 1 is 2. Can we see? What is the answer of which one? Print A, B. The answer is, I guess, 2. Yeah, answer is 2 right here. This is your right shifting. Whatever value is there, it takes that digit and make them 0. Then make them 0. Okay. One last operation of bitwise. Suppose I said just opposite. I said the same thing with one more operation called print A, B. Okay. 9 0 0 0 0 1 0 0 1, and it is asking me, can you shift this towards left? This is left shifting 2 times. What I'll do, I'll keep this 2 value, starting 2 values from this side, and place them this side. I'll take this 2 value and place them this side. Just like in earlier operation right shifting, I took value from there and shifted there. Now I'm taking value from there, I'm shifting there. Yeah, just opposite. So now it will be 0 0. Now it will be, this transformation will be 0 0 1 0 0 1 0 0. This is how it will work. And what is the interpretation of this in to the power? To the power 0 to the, so I'm just writing the value to the power 0, to the power 1, to the power 2. To the power 2 is there. To the power 2, to the power 3, to the power 4, to the power 5. To the power 5 is there. To the power 5 is 32, and to the power 2 is 4, which means my answer must be 36. If my concept is right. Can we see the answer? Let's rerun them. And perfect answer is 36. Have you understand clearly the use of this, 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 use of this? So ratio wise, if you ask me, we are using them 90% time, and we are using them 10% time. This is the ratio in our application can come, or internally if you want to explain something. Okay. So after this operator, assignment operator. So I'll go now. I think the rest of thing is not new to you guys. Only the bitwise was little bit new, though you have seen them also in C and C++. Assignment operator. Equal to, plus is equal to, minus is equal to, multiply, divide, modulus. This is what 7 by 5. So I can get answer as 1 point. If I say 7 by 5, I'll get answer as 1.4. And this is giving me just 1. This 0.4 will be ignored. So this will give me just 1. We know this also. This is exponent equal to, like I said, x is equal to 5. And I said x is equal to, or x exponent is equal to 5. Or I can even say x is equal to x in exponent of 5, which means 5 to the power 5. AND operator, OR operator, XOR operator, right shifting equal to left shifting equal to. So I think you can use this and see. This is the same thing we have seen in the previous example. A plus, I'll just take one example here. So I said A14, and then I'm saying A plus is equal to 10. The better interpretation of this I like technically writing this. So it gives me A is 14 already, so A will become eventually 24. That's what it is. This operation you have seen. So please do that. Check by yourself also, couple of them. Take it as assignment and do them. Yeah, Bhushan, sure. After knowing the approaches, we'll see how this bitwise can be used. Special operators. Last operator and special operators may we have two things. Identity, I said one, and second will come as a membership operator. Yeah. So total 7 operators. Can I just get the quick name? Arithmetic operator, logical operator, comparison operator, or relational operator, comparison operator, bitwise operator, assignment operator. This is a special identity and membership. Identity and membership. So total 4 plus 3, 7 different operators we have. Yeah, Bhushan, that's right. As in, you asking any question? A is equal to A plus 10, both the same. Both the same. Whatever you have written, both are same. Both will return me same value. Does way of writing way also impact performance? Okay, so performance you're asking. No, this thing will not hit me on the performance. Performance will mainly come in the memory side. Performance comes because of two things. So what element I'm storing? What element I'm storing? I'm storing, if I'm working with just one element, it's okay. Anyways, one element I'll need to take it. But if I'm working with a multiple elements, iterables, then there we need to check many things. Whether I'm using list, what is the operation of list? Whether I'm using tuple, in which situation I'll call tuple, what operations can be there? When I can use a set, when I can use a dictionary. So sometimes what happens, you can achieve the same answer using list and tuple. So that time we can see the performance of our memory, our execution, our interpreter, how much time it is taking to prove this. Okay, so time wise we can compare between multiple elements. If I'm storing within list, how much memory it is occupying. If I'm storing within the tuple, how much memory it is occupying. But if I say A is equal to 10 and B is equal to 10, anyways, we know that when A is assigned with 10, it returns me some number in a memory side, some address of hash value, and then B is equal to 10 will not be stored in the, will not assign this value in the different memory. It will just point out this memory. So this is, we can optimize our memory. So let's first understand how to write the code, and then anyways I'll take you to this, how to optimize the code. We have two scenarios in our approach. One is learning writing, and then second will go to the optimization side. Identity operators, and I said you guys identity operators is referred with two things. Just let me see the time. So quickly we'll complete. Okay, just we have 5 minutes more. Special operators is just two, is and is not. A is equal to 5 and B is equal to 5.0. This is integer, this is float. This is integer, this is float. Print id a, id b, both will have a separate address when I print. And obviously I'm saying A is not B. I'm saying 5 is not 5.0. That's right. That's true. Integer can never be float, right? But can I say, if I write here integer before 5, I'm just giving you one heck. If I do this, then answer must be false, because both are integer. And I'm saying 5 is not 5. No, 5 is 5. Integer is integer. Getting me? So this is clear. What is the use of is here? What is the use of is here? If I say A is B, if I say A is B, now answer will be false. A is not B, answer is true. So we just need to use is and is not to perform the identity. We are checking their identity. Second option, L1 is 1 to 3, L2 is 1 to 3, L1 is L2, L1 is L2, But why L1 is not L2? Can you guys give me answer of this? Why L1 is not L2? Anyone? We have seen this example, we have seen this operation in previous example. I am expecting answer to be true because I can see exactly same value for L1 and exactly same value for L2. Any reason why I'm getting false when I'm saying this is this? Yeah, this is this, right? Like if we see just number is looking same, syntax is very same, just a variable is different. Anyways, variable is not doing anything. L1 is having same thing, L2 is also having same thing. So why this line answer is false? Anyone? Why this line answer is false? Why this is returning me false? Guys, so I think if you see, yeah, so I think we get some response. Memory, both are saved at different address. Yeah, both of your answer is right. One is saved in when we are saving in a memory, both are having a different address, and if you see the line number just next to false, you'll see the address, both are having different address, and hence the answer is false. So only element can be stored in the same memory. This cannot be, this cannot be. But I will prove you I can do this also, but using a special library of Python which we call a numeric Python, a NumPy. In NumPy I'll perform couple of activities where you will find when L1 is equal to 0297 and suppose L2 also belongs 027, as in, can I say L1 is my superset and L2 is my subset? So in this case, I can say I can use this L2 and do not store a separate memory location. I can point this to L1. I can do that, but that can be possible using NumPy.